Hi everyone, welcome back. In today's lecture, we are going to study on important topic on integrated circuits like it is called comparator circuit and it is otherwise called Schmitt trigger and also known as regenerative comparator. The circuit is widely used in digital and analog systems to handle noisy input signals and to convert slow or distorted waveforms into clean digital signals. First, we'll before understanding the Schmitt trigger, first let us recall a normal comparator. So a basic comparator compares input voltage with a single reference voltage. If the input is greater, the output is high. If the input is lower, the output is low. But the problem arises when the input signal contains noise. Due to noise, input may be cross the reference level multiple times, output keeps switching rapidly. This causes false triggering and unstable output. So a normal comparator is not reliable in noisy environments. To overcome these problems, we can make use of the Schmitt trigger. A Schmitt trigger is a comparator circuit that uses positive feedback to create two different threshold voltages. Because of these two threshold voltages, one threshold for rising input, another threshold for falling input. This dual threshold action is called hysteresis. Due to hysteresis, small noise variations do not affect the output, making the circuit a very stable one. So the Schmitt trigger can be designed using an operational amplifiers or transistors and are available in two forms, that is inverting Schmitt trigger and non-inverting Schmitt triggers. So the Schmitt triggers are essentially in electronic devices for wave shaping and eliminating disturbances and which shows their versatility in handling the signals. So the regenerative comparators. What is hysteresis? The hysteresis means the switching capacity point depends on the previous output state. In Schmitt trigger, the output does not change immediately when the input fluctuates. It changes only when the input crosses specific upper or lower level. This is the key reason why this Schmitt trigger is also called a regenerative comparator because part of the output is feedback to the input to reinforce switching. Threshold voltages in trigger. So now let us understand in two important threshold voltages. The upper threshold voltage when the input voltage increases and output voltage changes only when the input exits the upper threshold limit. The lower threshold voltage when the input voltage decreases, output voltage state only when the input goes below lower threshold voltages. So between the upper threshold and lower threshold voltage, the output remains unchanged. Noise inside the band is ignored. This is region is called hysteresis band. A step-by-step working. Let us assume the input voltage starts from 0 and slowly increases. If the input less than upper threshold voltage, the output remains low. Next, if the input crosses the upper threshold voltage limit, the output switches to high and the input now starts decreasing. Even if the input falls slightly, the output remains high. Only when the input goes below lower threshold voltage, the output switches back to low. So thus then again when the input rises above the upper threshold voltage, the output becomes high. This repeated switching creates a clean rectangular output waveform across the output side of the Schmitt trigger. To take the waveform
So what
interpretation.
are the characters? This graph will show you the characteristics of the Schmitt trigger, that is inverting Schmitt trigger as well as the non-inverting Schmitt trigger. So the inverting Schmitt trigger will produce the output like this. So the green color will show you the positive that is upper threshold limit, and the red color will show you the lower threshold limit values and the responding output. Similarly, for the non-inverting semi trigger, the green color will show you the upper side, that is the mirror image of the inverting will give you the non-inverting semi trigger output. So the characteristics are hysteresis, noise rejection, bistable. That is bistable operation means it will momentarily changes between the upper threshold limit as well as the lower threshold limit. So if you consider the semi trigger as well as the normal comparator, there is some dissimilarities. So if you consider the comparator, if it is a open loop, it will produce only two signals. Either it will reaches the plus V saturation or it will minus V saturation. It won't give the output in between, but it implements the hysteresis by using positive feedback. If you use a open loop configuration, it that is normal comparator has a, it doesn't have any feedback, but symmetry here has a positive feedback. in in a normal comparator, it doesn't have a threshold limits, two threshold limits. It has only the reference voltage. The output is decided based on the reference voltage only, but in the semi trigger, it is depends upon the upper threshold limit as well as the lower threshold limit. Here the hysteresis is not present, but in semi trigger the hysteresis is present. That is, the hysteresis is taken as the upper threshold limit to lower threshold limit. Here the external V reference is given. Here the output is taken as the reference voltage, so there is no need of external reference. It will the general application of the comparator is, it has a zero crossing detector or window detector like that, but it is used to convert any waveform into a square waveform signals. So generally the output of the regenerative comparator or symmetric trigger is a square waveform.
So the next we'll discuss the symmetry trigger applications. The application of the symmetry trigger are given below. The symmetry trigger used to convert the sine wave into a triangular wave into a square waves. The most important use of the symmetry trigger is to remove the noise in the digital signals, and also it is used for switch debouncing, oscillators and function generators, signal conditioning circuits. To take it to the conclusion, a symmetry trigger is an important in linear integrated circuit as an improved comparator, uses positive feedback and hysteresis, provides clean and stable output, essentially in noise signal environment. In the next lecture, we will discuss on some other topics. Hope this lecture will give you an insightful about the symmetry trigger or a regenerative comparator or closed loop comparators. Hope we will meet in the next video. Thank you.